Hello students, today we are going to discuss about HSAB. HSAB means hard and soft acid bases. In general, metal reacts with ligand to form coordination compound. This is the metal reacts with ligand to form coordination compounds. If metal always accept the electrons from ligand, hence the scientists state that metal acts as a Lewis acid. On the other hand, ligand donate the electrons to metal, hence ligand acts as Lewis base. Finally, the coordination compounds formation by interaction of Lewis metal and Lewis ligand. It is Lewis base, it is Lewis acid. The chemistry scientist states that the metals the metals or metal ions are classified into two classes. They are class A and class A. The chemistry scientists state that the metals or metal ions are classified into two classes. They are class A and class B. On the other hand, ligands also classified into two types. One is class A, another one is class B. Class A now. Class A now we will discuss class A. Class A have small size alkaline metals, small size alkaline earth metals and lighter elements with higher oxidation states or belongs to class A. What are class A? Small size alkaline metals, small size alkaline earth metals and lighter elements with higher oxidation states are belongs to class A. Examples: lithium plus, sodium plus, potassium plus, beryllium plus 2, magnesium plus 2, calcium plus 2 and titanium plus 4, ferrous plus 3, cobalt plus 3. Here, students, lithium, sodium, potassium are first year group elements. Now we will discuss clearly. In periodic table, lithium, hydrogen, lithium, sodium, potassium, rubidium, cesium. This is the group in periodic table. It is the first year group and also known as alkali metals. In general discussion, from top to bottom, sizes are increases. That's why here lithium is small size metal, cesium is large size metal. Just for understanding only, it is only for understanding purpose. This is a group of periodic table: hydrogen, lithium, sodium, potassium, rubidium, cesium. From top to bottom, size is increases. So lithium is small size, cesium is large size. Just for understanding purpose, this is the concept. So that's why already we discussed the definition. What is class A? Small sizes are class A. So that's why lithium plus, sodium plus, potassium plus are class A, belongs to class A. In second group, now we discuss second group elements: beryllium, magnesium, calcium, strontium, barium, radium. Students, beryllium small size, beryllium as small size, radium as large size. So except these two, beryllium, radium, these all are class A. These two are belongs to class B. It is just for understanding, students. So that's why magnesium, beryllium, calcium are belongs to class A. Here titanium, ferrous, cobalt are lighter elements. Titanium, ferrous, cobalts are lighter elements, means 3D Sreni elements. 3D Sreni and 4D Sreni elements are lighter elements. 6D Sreni elements are 3D, 4D, 5D. 5D Sreni elements are heavier elements. So lighter elements with higher oxidation states, high positive charge, is called belongs to class A. So easily remember. Always next, class B. Students, class B is reverse to class A. What are class B? Class B are large size alkali metals, large size alkaline earth metals, and heavier elements with lower oxidation states are belongs to class B. Students, what are class B? Large size alkali metals, large size alkaline earth metals, and heavier elements with lower oxidation states are belongs to class B. Students, already we discuss hydrogen, lithium, sodium, potassium, rubidium, cesium. This is the group of one of the group of periodic table. Already discussed. Top to bottom sizes are increases. Atomic sizes are increases. That's why here lithium is small size. It is class A. It is belongs to class A. Cesium is large size. It is belongs to class B. But these first A group elements, alkali elements, are low electronegative elements. The based on definition of class A, except cesium, hydrogen H plus, lithium plus, sodium plus, potassium plus, rubidium plus belongs to class A. Only cesium is belongs to class B. Just for understanding purpose, students, class B, cesium plus, thallium plus, it is belongs to third A element. It is third A element. Next to copper plus, Ag plus, Hg plus, Hg2 plus, platinum plus 2, palladium plus 2. Copper, Ag, Hg, platinum, palladiums are heavier elements. Already the definition is heavier elements with lower oxidation states, mean lower positive charge, less positive charge. So therefore these are belongs to class B. Next, class A ligands. Class A ligands, class B ligands. Metal classified into metal or metal ions are Lewis acids. Lewis acids are classified into two classes, class A, class B. Ligand acts as a Lewis base. Lewis bases are classified into two classes. One is class A, second one is class B. Students, class A ligands are NH3, F minus, OH minus, O minus 2. Students, just for understanding, it is only for understanding. Boron, carbon, nitrogen, oxygen, fluorine. BC NAF. Third A group element, fourth A group element, fifth A group element, sixth A group element, seventh A group element. It is period. Carbon 2.5 electronegativity, nitrogen 3.0, oxygen 3.5, fluorine 4.0. So according to electronegativity, boron, carbon, nitrogen, oxygen, fluorine, these are more electronegative elements. These are more electronegative elements. In NH3, nitrogen is present. In H2O, nitrogen is present, F minus. From top to bottom, sizes are increases. That's why carbon, nitrogen, oxygen, fluorines are small sizes. Nitrogen, phosphorus, I am writing group, nitrogen, phosphorus. I draw nitrogen group, nitrogen, phosphorus, arsenic, antimony, bismuth. In group, from top to bottom, atomic sizes are increases. That's why nitrogen is small size, bismuth is big size. So nitrogen containing compound species are class A, belongs to class A. Nitrogen containing species are belongs to class A. Next, phosphorus containing compounds are belongs to class B. Just for, it is only for understanding. Students, nitrogen have small size. That's why nitrogen containing compounds are class A, NH3, NH2R, NR2, like this. Phosphorus containing species are belongs to class B. Why? Because compared to nitrogen, phosphorus is a large size atom. Next, it is only for understanding. Next, oxygen family. I draw oxygen family: oxygen, sulfur, selenium, tellurium, polonium. From top to bottom, sizes, atomic sizes are increases. So oxygen have small size. Oxygen has small size compared to sulfur, large size. From top to bottom, atomic sizes are increases. So hence oxygen containing compounds are small size. Sulfur containing compounds are large size. That's why sulfur belongs to class B, oxygen belongs to class A. Oxygen belongs to class A. Next, fluorine, chlorine, bromine, iodine. Students, it is very important before we going to explain HSAB. These fundamentals are very very important before we going to enter into the HSAB chapter. So, from top to bottom, sizes, atomic sizes are increases. That's why fluorine is small size, fluorine has small size, iodine has large size. So small sizes are belongs to A, class A. Small size atoms are belongs to class A. Iodine is class B. This is the concept. So that's why class A ligands are NH3 containing, fluorine, oxygen containing. Class B, H minus, R minus, I minus, sulfur containing compounds, phosphorus containing compounds, Cn minus, SCn minus, etc. This is the class A ligands and class B ligands. Now, Pearson's classification of acids and bases. First we discuss hard acids. Hard acids are small ionic radius, high positive charge, low electronegativity, high energy lumen. Students, metals are having lumen, ligands are having HOMO. Why? Because ligands are donor atoms, metals are accepting the electrons. Whenever acceptors are having lumen, whenever metal is accepting electrons, whenever metals are having lumen. What is here? H means higher, high energy lumen. Students, very easily to understanding, we remember hard acids are small ionic radius, high positive charge, low electronegativity, high energy lumen. Next, now we coming to example: H plus, Li plus, sodium plus, potassium plus. These are small ionic radius. That's why these are belongs to hard. H plus, lithium plus, sodium plus, potassium plus are belongs to hard acids. Already we discussed metals are acts as a acids, Lewis acids, but based on the small sizes acids are hard acids. Pearson states that instead of class A belongs to class A instead of class A into hard acid. Pearson introduced hard and soft terms instead of class A and class B. Second, this is the example: beryllium plus 2, magnesium plus 2, strontium plus 2. These are have small size, so belongs to hard acids. Sn2 plus, next aluminum plus 3, gallium plus 3, indium plus 3, chromium plus 3, cobalt plus 3. Here chromium, cobalt, ferrous are heavier, lighter elements. Chromium, cobalt, ferrous, titanium, zirconium elements are lighter elements with high positive charge. So, by the definition, lighter elements with high positive charge are belongs to hard acids. This is the hard acids. Very simple. Pearson states that Pearson introduced instead of class A and instead of class B. Class A instead of class A into hard acid, instead of class B into soft acids. Next we discuss soft acids. It is opposite to hard acids. What is soft acid? What are soft acids? Soft acids have large ionic radius, low positive charge, intermediate electronegativity, low energy LUMO. Low energy LUMO. Hard are high energy, H. In high energy, H. In hard acid, H. It is only for understanding. Low energy LUMO, soft low energy, hard high energy LUMO. Students, already we discussed cesium has large size. Cesium has large size. So, large ionic radius are what? Soft. So, cesium belongs to soft acid. Copper, Ag, Hg, thallium, Hg2 plus, palladium plus, cadmium, platinum plus 2. These are heavier elements with low positive charge. These are heavier elements with low positive charge. So hence these all are called soft acids. These belongs to soft acids. These all are belongs to soft acid. What is the definition? Large ionic radius, low positive charge, intermediate electronegativity, low energy LUMO. Low energy LUMO. This is the soft acids. Now next discussion. Next. Hard bases. Now we discuss about ligand. Ligand nothing but base. Bases. Lewis bases. Hard bases. Hard means small size, high electronegativity. Hard means small size, small ionic radius, high electronegativity. Dear students, F minus, simple example is the right side elements are bases. In periodic table, the right side elements are bases, left side elements are acids. Some just for understanding only. Students, F minus is a small, F minus as small size. That's why it is hard base, and also it has high electronegative atom. It has high electronegative atom. That's why small size, small ionic radius, high electronegative belongs to hard bases. And another new topic is weak polarizability. Hards are weak polarizability. Hard bases are weak polarizability. High energy HOMO. Already we discussed bases have high HOMO. Bases are containing HOMO. Acids are containing LUMO. Acids are containing LUMO. Bases are containing HOMO. H means high energy HOMO. These are the hard bases. Dear students, oxygen is what? Small size. Oxygen has small size. So oxygen containing is hard. Oxygen containing species is hard. Oxygen containing species is hard. Oxygen containing species hard. Students, nitrogen has small size. Small sizes is what? Hard. So nitrogen containing species is hard. Nitrogen containing species is hard. Nitrogen containing species is hard. F. Fluorine. Fluorine is what? Fluorine has small size. Small size is referred as hard bases. Small size referred as hard bases. That's why F minus is a hard basis. So many examples. These ions are all ions are belongs to hard bases. Now students, now soft bases. Soft bases. Soft means large size. Soft means large ionic radius. Intermediate electronegativity. High polarizability. Soft means high polarizability. Low energy HOMO. Low energy HOMO. H means high energy. S means low energy HOMO. Low energy HOMO. Now, students, already we discussed nitrogen, phosphorus, oxygen, sulfur. Nitrogen has small size, oxygen has small size. Compared to nitrogen, phosphorus has large size. Compared to oxygen, sulfur is a large size. So, phosphorus containing species are soft. Nitrogen, phosphorus, oxygen, sulfur. Based on definition, large size atoms containing species are belongs to soft acids. Here, sulfur is large ionic radii. Sulfur has large ionic radii. According to definition, sulfur containing species are soft bases. Phosphorus is a large ionic radii. Phosphorus has large ionic radii. According to definition, phosphorus containing species are soft bases. Next, I minus, very important, I minus. Fluorine, chlorine, bromine, iodine. Iodine is large size and have high polarizability. So, according to this definition, iodine belongs to soft bases. Very simple, very easily to understand. Small size atoms, small size metals are belongs to hard. Large size metals are belongs to soft. Very easy. Just we have basic things. What is small size? What element have small size? What element have large? Which element has large atom? Which element is small size? Which element has small size? That is the main concept. Students, it is enough today. Next class